Question 12. We want to use the method of mathematical induction to prove that 1 squared plus 2 squared plus 3 squared and so on up to n squared is 1/6 n, n plus 1, 2n plus 1 for all n greater than or equal to 1. We start with the initial case, in this case n equals 1. The left-hand side is just then 1 squared, which is equal to 1. The right-hand side would be 1/6 of 1. 1 plus 1 is 2. 2 plus 1 is 3, so that's 1/6 of 6, which again is 1. So we can say that this is true for n equals 1. Now for the inductive step. We assume for n equals k. So we're assuming that for some value k, 1 squared plus 2 squared plus 3 squared and so on up to k squared is 1/6 of k, k plus 1, 2k plus 1. Then consider the next case. So n is k plus 1. 1 squared plus 2 squared plus 3 squared and so on up to k squared, then add the next one, would be equal to 1/6 k, k plus 1, 2k plus 1 plus k plus 1 squared. The idea is that this is assumed to be true. If this is true, this must be true because all we've done is add the same thing to both sides. Now let's work with this right-hand side. The idea is to get this expression with the k's replaced by k plus 1's. So we're looking for 1/6 k plus 1, k plus 2. This would give us 2k plus 2 plus another 1. So 2k plus 3. And it's a good idea to write down your target expression. So this is 1/6 k, k plus 1, 2k plus 1, and I'm going to write this as 1/6 times 6 k plus 1 squared. Then I can take out a common factor of 1/6 k plus 1. What do we have left? We've got k, 2k plus 1, and we've got 6k plus 1. So that's 1/6 k plus 1, 2k squared plus k plus 6k plus 6, which is 1/6 k plus 1, 2k squared plus 7k plus 6. 1/6 k plus 1, and this factorizes into k plus 2, 2k plus 3, as required. All you need then is a closing statement. I would use something like true for n equals 1. If true for n equals k, it's true for n equals k plus 1. So true for all n greater than or equal to 1 by the principle of mathematical induction. In part B, we're asked to find the limit as n tends to infinity of 1 squared plus 2 squared plus 3 squared all the way up to n squared all over n cubed. We know that's the limit as n tends to infinity of 1/6 n plus 1 2n plus 1 all over n cubed. If we were to expand the top, we would end up with 1/6 of 2n cubed, which is 1/3 n cubed, and we'd have some other terms. The other terms won't matter because deciding what happens when n goes to infinity only involves the highest powered term. If we just divide these, we get 1/3, and that will be the limit.